Hello, dear students. Welcome back to my YouTube channel. I hope I'm audible and visible to all of you. Hello, 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 hello. Let me check the connectivity firstly. Then I will start. Okay, 1 second. So I'm audible and very visible to all of you. So what can we do, right? Provide me 1 second. Okay. Okay. So as you know that up to now we have completed many topics like oblique projectile motion and horizontal projectile motion. If we are throwing something up from the building, or if we are dropping something from the building, or if we are throwing something down from the building, from the grounds also, right? So we had done all these things, and last lecture was all about the relative motion. Now we are only left with two topics. One is a river boat problem, second one is a rain problem, a rain man problem and a river boat problem. So these two things we will be discussing in this particular class. And if you want to ask me anything, you're most welcome. So today what we will be discussing, firstly we will start from the river boat problem. And if you find the numerical from your PYQs, I guess 2 times the numerical has been asked from the same topic. Okay, that means river boat problem is important, but not that much of importance, right? And the rain problem is not that important, right? But still, if you want, you can just go through with these things, because we don't want to lose any single number from our examination. That's why I'm just giving you all these possible things, right? So now let us start. Let us start. 1 second. Okay, so let's start now. I hope my screen is very visible to you and I am also audible to you now. So let's start the class, and I won't take your much time. So let's start from the very beginning, and the beginning would be like 1 second. Okay, so right now, a river boat problem. Okay, suppose we are having a river. This is my river. In this river, water is flowing. Okay, in this river, my water is flowing. So these are tides of water going from left to right. This is VR. VR means velocity of the river. Okay, and here is a person, and if person is going in this way, I can write VMR. So you will find three notations. VMR means velocity of man with respect to still water. With respect to still water. That means if my water is still, it is in the position of rest. So the person can move inside this river with a VMR speed, VMR velocity. Okay. And what is VR? VR is velocity of river from ground frame. From ground frame. That means if somebody is at the particular point, right? This, right? So for this particular person, the river is going with speed of VR. And VAM means velocity of man with respect to ground. That means, look now, if we are standing in the river and the river is flowing with some velocity, so you will feel some drag, you will feel some push from the river's end. okay, you will get dragged to somewhere else, right? If the person is noting down your speed, so the speed with respect to the person is known as vm, velocity of the man with respect to ground. Now we will discuss some cases. It is not that much of difficult, so I will discuss case number first. Case number first is, if the man if the man swimming if the man swimming downstream or along the river flow, along the river flow. That means if the velocity direction of river and of that person is same, so what you will write? You will write VMR. Velocity of man in settled water will be equals to velocity of man minus velocity of river. Why, sir? Because both are in going same direction, that means minus thing is used. So what you will write, velocity of man with respect to ground, it will be velocity of man in still water plus velocity of the river. Done. If you find it is magnitude, so you can see now, look, if person is going in the direction, I cap. If rain water is going also this direction, that is I cap. So can I write now vm equals to vmr I cap plus vr I cap. Done. Or I can write vmr plus vr, both are in I cap. So what is vm? Velocity of man with respect to ground magnitude, that will be vmr plus vr. That means if the person is going along the river, so the speed of the person equals to speed of the person in still water plus speed of the person in the river. Case number first. In the same way, if we need to write down case number second, case number second means if the river is going in this direction, vr is going in I direction, but the person is going in opposite direction, minus I. So how will you will write? So vm, is it vmr? Yes, sir, but vmr is minus I cap plus vr would be in plus I cap. So what is vm now? So I can write vm equals to vr minus vmr, both are in I cap. So what will be? It is magnitude. So the magnitude of vm will be equals to vr minus vmr, or positive deviation, that means vmr minus vr. Both are same. It is positive deviation. Last time we discussed about what is minus, right? Now we have some specific cases. We have some specific cases. That means if vmr is more than vr, or if vmr equals to vr, or if vmr is less than vr. If vmr is more than vr, so the person will move opposite direction of the river. Okay, if let us suppose this is my river, and if the person is going in this way, river is going in this way, river, okay, and if vmr is more than vr, so you will see from the ground frame of reference, you will see the person is going upside, opposite to that of the river. But if vmr is equals to vr, a person is all the situations, even though a river is going downwards and man tries to go upwards, okay, so you will see man is still neither going downwards nor going upwards. Third one, if vmr is less than vr, you can see man tries to go upwards, but you will see from this perspective it gets drifted towards the direction of the river. Drifted, बहा के ले जाना, drifted towards the right end. Done. These were some cases of river board problem. Okay. Done. Okay, let us discuss that some numericals. Some numericals. Numerical first. A man tries, or I will take different numerical. Good one. A man takes 2 hours to go 8 kilometer and comes back in still water. In still water. If water starts moving, if water starts moving with 4 kilometer per hour now, then find out time, find out time taken to go 8 kilometer in upstream and return back. Okay, so first part is, in the first part it states that if water is still, a person takes 2 hours kilometer up and down. So in the first scenario, what will be the speed of VMR? Total distance would be 8 plus 8. Total time taken in 2 hours. So you will write it 8 kilometer per hour. So the speed of the person in still water is 8 kilometer per hour. Now upstream. Upstream. Now as the flow of water begins with a 4 kilometer per hour. So let us suppose in first time upstream. Okay. This is my channel. Water is going in this way. This is 8 kilometer. 8 kilometer. It is going 4 kilometer per hour. A person is going from this end towards the leftwards. So whatever I will write now, I will write time taken, T1. It will be total distance is 8 kilometer divided by velocity. What is velocity? Look, river is going in this direction and man is going in this direction. Both are opposite. So you will write VMR minus VR. How, sir? Look now. Okay, in opposite cases. So now 8. VMR is 8, VR is 4. So I can write here 8 by 4, that is 2 kilometer per hour. Sorry, 2 hours. Now T2, downstream. Downstream, that is T2. Same, 8 divided by, but now the person is going along the flow of the river. Back, na? Person goes from this end and here it returns back. I can write VMR plus VR. Now 8 divided by 8 plus 4, that is 8 divided by 12, that is 2 by 3 hours. What will be total time? It will be T1 plus T2. T1 is 2 hours plus T2 is 2 by 3 hours. I can write 2 by 3 multiplied by 60. It is 40 minutes. It will be 40 minutes. So my total time will be 2 hours 40 minutes. 2 hours and 40 minutes. Done? Okay. One more numerical. One more numerical. I will write here. A boat moves in a river. A boat moves in a river between two fixed points, A and B. It takes time T1 when going upstream and time T2 in going downstream, then what will it takes to travel AB in still water? Okay, opposite case of the first one. So how you will write the solution of this part? A boat moves in a river between two fixed point A and B. If it takes T1 time to go upstream and T2 time in going downstream, then what will it takes to travel A to B in still water? Okay, okay. First part is upstream. First part is upstream. In upstream manner, river is going in this way, a boat is going in this way. Done. So we know that T1 equals to distance by VMR minus VR, or you will write here now VMR minus VR equals to D by T1. Now second point for downstream. For downstream, so what you will write now, you will write same VMR plus VR came out to be D divided by T2. Add both these equations, so I will get VMR minus VR plus VMR plus VR equals to D divided by T1 plus D divided by T2. So my answer came out to be 2 times VMR equals to D T2 plus T1, that means T1 T2. So what do we have to find out? Then what will it takes to travel AB? So we have to find out T. Done? Okay, so what is VMR now? VMR divided by D, it will be T2 plus T1 2 times T1 T2. So D by, so I will, if I just reciprocal the whole thing, I will get D divided by VMR equals to 2 times T1 T2 divided by T1 plus T2. D divided by VMR is T. So is it T equals to 2 times T1 T2 divided by T1 plus T2. This is the time. And you will find a numerical based on the same topic in your NCERT. Done? Clear now? Okay. Look now. We are having now a river. We are having a river now. This is my river. Okay. And width of the river is something like this. And we threw something in this direction. Okay. I will firstly make all these notations, then I will write everything. Okay, look now. This is my river with the width of D. Okay. First case, if you will find the shortest path, if you find the word shortest path, if a person wants to cross the river via shortest path between 2 points is only the perpendicular direction. But here you will see current velocity. The velocity of the river is going rightwards. If the person jumps in this way due to the current, he will go in this direction. So to get this thing clear, a person jumps via some angle. A person jumps via some angle. Okay, so I will write here person jumps from some angle theta. This is my velocity of my man in still water. Why? Look now, we can make two components. One component is VMR sine theta. Here is VR. One component will be along this line. This will be VMR sine theta. This angle is 90 degree. Done. Now, if a person wants to cross this AB line, in this particular way, my VMR sine theta should be equal to VR. Okay, so I can write VMR sine theta, it should be equal to VR. Why? Because this velocity component will cross this one now, then only VMR, the person will go from A to B in a shortest path manner. So you will find what will be the angle of projection. So you will write V sine theta is VR divided by VMR, or you will write theta equals to sine inverse VR divided by VMR. But that particular angle is from what? Is from vertical. But if you find from this way, that means let us go, it is alpha. It is alpha. So what will be alpha? Alpha means 90 degree plus theta. It will be 90 degree plus theta. Now what is time taken? Time is distance by speed. Distance is d. Speed will be VMR cos theta. VMR cos theta. Done. Now look now. Look now. We have now angles, right? So this particular thing is, okay, it is cos theta, no? It is cos theta, sorry, cos theta. So I will write here VMR cos theta. Done. And this one is my VR. And this angle will be my VMR. If this one is theta. So what will be VMR cos theta? So by Pythagoras theorem, so I can write it equals to VMR square minus VR square root distance. If you want to write VM, what is VM? So a person can see the person is going along VMR cos theta. So you need to write the whole things so that you will revise these things, right? How to get these VMR cos theta by applying the Pythagoras theorem. What is VM? If a person is standing on the bank of the river, so he will see the person is going along the AB line. Why? Because internally the VMR sin theta is cancelled by VR. That's why. Okay. It was a shortest path. Second point is shortest time. Shortest time. Shortest time. Look now. Width of the river is D. Person goes along this way, VMR, but due to the current of the water, due to the water motion, he goes in this direction. So person gets dragged this x distance. Done. So we know it is VMR, this will be VR. A person seeing from the ground, he will see this is VM. Okay. So my time was d divided by VMR cos theta. If d is fixed, now t needs to be minimum. It should be maximum. How to be maximum? My cos theta should be maximum. And cos theta is maximum when theta is 0 degree. When theta is 0 degree. That means if a person is going along this line, perpendicular this line, okay, because this was theta, na? If now theta is 0, so you will get what? A shortest time. So d is equals to d divided by VMR only. So my time came out to be d divided by VMR only. If somebody will ask you what is alpha, so alpha was 90 degree plus theta. So my alpha is equals to 90 degree only now. What is drift? Drift is distance, right? Caused by VR. So I can write drifted. Distance is speed into time, t. X VR. What is time? Time is nothing but d divided by VMR. Done, no? So now let us do 1-2 problems. Then tata, bye bye. Tomorrow we will be doing a rain man problem for 15-20 minutes. Then everything will be sorted then. Okay. Question number 1. A river of width 100 meter is flowing with speed 10 meters per second. A man can swim with speed 5 meters per second in still water. Then, if he wants to cross the river in minimum time, firstly, speed of man, Vm. Second point, time taken to cross the ground, river. Third, drift. So first thing what we need to note down now, look, a river of width 100 meter, that means d is given as 100 meter, is flowing with speed. So VR is given to us 10 meters per second. A man can swim with speed 5 meter per second in still water, that is VMR given as 5 meter per second. If he wants to cross the river in minimum time, so T equals to D divided by VMR. Okay. Then speed of man. So look now, Vm, speed of man, it will be VMR plus VR. VMR plus VR. VMR is in I direction and VR is I and VMR is J. Why? Look now, from previous case, look, river is going in this direction, that means I. Man goes in this direction, that means J. So my Vm is equals to VMR, it is J, plus VR, it is I. Okay. So if you need to take it as magnitude, so you will write VMR square plus VR square root. Done. VMR is 5 square, VR is 10 square root. It is 125 root. That means 5 root 5 meter per second. First part. Now second part. Second part is time. What is time now? T equals to D divided by VMR only. D is 100, VMR is 5. I guess my answer came out to be 20 seconds. Drifted. Drift is X equals to VR into time. What is VR is 10, time is 20, that means 200 meter. So drift here is 200 meter. Done. In the previous case, VM was VM cos theta, VMR cos theta, but in this case, it is VM j cap plus VR I cap. Done, beta? Okay, one last numerical from the class. Last numerical is, if the width of the river is 1 kilometer, velocity of river is 1 kilometer per hour, and VMR is given as 2 kilometer per hour. Now the whole thing is for shortest path. The whole thing is for shortest path. For shortest path. Firstly, speed of man in ground frame. First thing that we have to find out. So I guess speed of man in ground frame is equals to VMR cos theta. Done. Is it VMR cos theta? Okay, no? So, but we don't know what is cos theta, right? We don't have any idea about cos theta. But one thing that is given to us, we know that VR is equals to VMR sine theta. Okay, VR is 1, VMR is 2 equals sine theta. So my sine theta came out to be 1 by 2. It is equals to 130 degrees is my angle. So I can write VM equals to VMR is 2 into sine theta is cos theta is under root 3 by 2. So my answer is root 3 meter per second. No, it is kilometer now. So I can write kilometer per hour. Firstly. Second thing, time. Time is d divided by VMR cos theta. What is d? D is 1 kilometer and VMR cos theta came out to be root 3. It is 1 by root 3 hours. What is alpha? Alpha is 90 plus theta. So alpha is 90, theta is 30. So 90 plus 30, 120 degree. Okay. So we are done with these cases now. So now only one lecture needed. Only one lecture. So that means tomorrow one topic for 20 minutes, that is a rain man problem. So tomorrow sharp at 8 p.m. we will start the rain man problem, and in less than 20 minutes we will complete the whole topic. Then we will start NLM in my next class. Done, beta? I hope everything is great now. One second. Okay, one more thing, right? So I got a lot of requests that I need to start the English lectures. So what I am thinking now that from, I guess from next week I will be starting a English lectures also. So I will be starting English lecture series for the upcoming examinations. So for that thing, if you have any kind of suggestion now, you can just ping me a comment below for the suggestion part. Okay. So I will start English lectures, the lecture of 11, 12 from the very basics for 3 months course. So October, November, December. Okay. So for these 3 months course, I will be starting the 11th and 12th in English. Full English. Yeah, I will be continuing the English lectures. Why? Because I completed English 12th. Now we are left with English 11th. So I will be starting. I will be ending the 11th soon. English one. So in the meantime, I will be starting English 11th and English 12th. Okay, and I will just make sure that you are very ready for examination. So I will be launching Sundays the PYQ series, the NCRT series, right? So make sure to subscribe the channel, and if you want to ask me anything, if you have any query, or if you want suggestions, or if you have anything, na, that's what I want these things to be done, or I am having these issues for that particular chapter, right? So make sure to just comment, or if you are like shy person, if you don't want to comment, so below the channel you will find my Telegram group. So in my Telegram group, what you need to do, right? You will find my personal Telegram links. So there you can send me the message personally, right? So if you have any problem with your NEET and JEE 2026, you can just send me those issues that you are having. So I will be giving the very best solution that I'm having for your things. Okay. I hope you enjoyed the session. And if you have any things that you want to let me know, you are most welcome. And be prepared for English lectures as well. Okay. And also I will be starting, I guess, foundation courses for NEET and JEE. Foundation, not for only foundation. 9, 10th. I will be starting 9, 10th. But the 9, 10th will be for foundation of NEET and JEE. It will not be for the board examination. Okay. But that plan is for winters, Jan, Feb. Okay, beta? So I guess don't have any problem now, and we are done with today's topic. And if you want to ask me anything, and if you want like me to ask anything, you're most welcome. If not, then take care. Bye. Good night. Bye, beta. Good night. Bye. Thank you. Bye. And I will be sharing the notes, right? I will be sharing these all notes to my Telegram channel. So at the last class, and if you don't have subscribed in my channel, do subscribe the Telegram also, so that you will get a regular updates regarding what I'm going to start for those things, and the notes one also, right? And I have shared the books of PYQ there also, the NEET one and the JEE one, so you can do those things there. I will be sharing a very good important stuff for examination as well, free of cost, no? Free, everything will be free. Thank you, beta. Bye. Good night. Take care. Bye.